Recording. Full screen. Now I think it is better. Okay. So this is week 3. Today we will going to solve a lot of questions about point group. So let's say consider this, and also you guys also have to solve with me. I'll give you questions and then. Okay, I think we have left here BF3. And VF3. So this is the structure of VF3. Let's find out what are the point groups, like the symmetry elements present in here. So first we have to find out axis of symmetry, plane of symmetry, center of inversion, then asymmetry and improper axis of symmetry. And I have told you again the point group, so you have to find out the point group. Okay. So tell me, what are the point groups, what are the symmetry elements are present in BF3, this molecule? Yes. If you are able to speak, you can speak, or if you are able to write it, just type in the chat box. C3, yes, then what is the plane of symmetry? Just tell me now, what is the plane of symmetry here? Please solve, or tell me. Nafa, you also tell me the point group of this molecule, axis of symmetry, point group, center of inversion, axis of symmetry. Tell me what is the this axis of symmetry. Patlekha already told. Tell me what is the plane of symmetry of this molecule. Today we have to solve a lot of questions because this is third week. Introduction is over. So, are you able to listen to me, guys? Okay. So, Patlekha is saying sigma V. So, this is your here. Let's say at here. This is your planar molecule. This is your planar molecule. This is your planar molecule. So, this is your C3. This is your C3. So, this is the perpendicular plane which is considering all the 4 atoms of the molecule, which means it is perpendicular to this axis also. This should not be sigma B. This is sigma H. So C3 sigma H. Now, center of inversion is there or not? I. No, yeah, center of inversion is not there. And then IOS, this improper axis of symmetry. Okay, anyway, then now we are going to find out the, obviously sigma V is also there, but sigma H is also there, 3 sigma V is also there. So what is the point group of this molecule now? Actually, I told you to find out sorry, D3H. Yes, because C2 is also present here. This is your C2. So 3 C2s are present here. So these are perpendicular to this. This is your planar molecule. This is C3 and this is C2. C2, C2. So C2 is perpendicular to C3. This means you will get the D point group. Simple. Nothing else. And this is your principal axis, so D3 is here. Why this S is coming? Because this is perpendicular. First after finding out this D3, what we go what we look for? The plane. Again, we have look for the plane. So this is your plane, which is perpendicular to this axis. This is your principal axis. So H, molecular plane. Okay, anyway, next, moving to this example. Whenever you guys have doubt, just stop me and tell me. Tell me, what are the symmetry elements are present? Axis of symmetry, plane of symmetry, inversion, center, IOS, and then finally the point group. Today at least we will going to solve what C3. Yes, C3 is there. C2 is also there. How many C2s? Yes, 3 C2s. Then anything else? Plane. Yeah, sigma S is there. And are you able to see sigma V? How many sigma V's are there? 3. Yes. Inversion? Yes, it is not present. Then okay, we will find out this. But this is these two are perpendicular. I guess if you are able to find it. C3 is going from here, from the top. This is planar, going from the top, and C2 is like this. This is your C2. This is C3. This is C2. This is C2. This is C2. This is C2. So these two are perpendicular. C3 C3 is perpendicular to C2, which means which point group you will get? D. What is the principal axis? 3. D3. Now, do we have the molecular perpendicular plane to the principal axis? Yes, we have. So D3H. Point group is D3H. Next, this one. This one. Tell me. This is rectangle. Rectangle. Yes. C2. C2. Yes, C2 is there. How many C2s are there? Uh, C2. Okay. So this is your C2. This is your C2. This is your C2. This is your C2. And this is also your C2. So 3 C2s, I believe. Right? And all of them are perpendicular to each other. So C2 is perpendicular to C2's, two C2's. Let's say all of them are perpendicular. So which point group we will going to see? D. Now what is the principal axis here? I have told you this is rectangle. So D2. Now rectangle, this is planar. This is your C2 perpendicular to this axis. This axis of symmetry. This axis. So this is D2H. Point group should be D2H. Now again, similar to this is a square. Now tell me, C4, yes. Okay, 3 C2s. Sigma H, yes. Sigma V, how many sigma V? Okay, whatever you are saying, I'm writing your name. Just this is your response. Okay, how many? 2. Okay, 2 sigma V. Next, C4 is correct. One C4 is there. This is your planar molecule, square. So 90 degree, 90 degree, 90 degree. So C4 is there. Yes, this is right. For C2, how many C2s are there? If you, this is your axis, C4 is also there, but if you rotate it by 180 degree, C2 is also there. C2 is also there. C2 is also there. So how many C2s are there? 3. But you have said 3, but there is one more C2 is present. Because this is square, this is also a diagonal. This is your also C2. This is your also C2. So I guess it should be how many? 1, 2, 3, 4, 5. Yeah. Because these are same. These are same. A, 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 A. So let's say this is your axis. This is half. This is half. Similarly here, one is going from here. Now this diagonal. This. This will come here. This come here. This will go that side. 1, 2. After this, what will happen? 2, 1, like this. Okay. So like this also, here is also one. So 5 C2s are there. Now sigma H is this sigma H. This is C4. This is plane sigma H. Now tell me how many C2s sigma V's are there? Okay, you are able to see four sigma V's. So this is your let's say this is your plane square. This is 1 sigma, 2 sigma, 3 sigma diagonal, 4 sigma diagonal. And this sigma is sigma H. So yes, 4 sigma. So 4 sigma Z. Now tell me what is the point group? Yes, D4H. This is correct. Now let's come back to next example, H2O2. Now I'm giving three situations. Cis, trans, and one is open book. You must have heard it. This is your trans. And open book will be like this one. Yes. Now tell me, what is the point group of this? If you are able to see the, like, directly able to calculate the point group, it is much better. If you are not able to calculate the point group directly, then follow the procedure I am following. Like, first determine the axis of symmetry, then plane of symmetry, then again center of inversion, then improper axis of symmetry. Then you will easily find out what is the point group of these molecules. So, okay, tell me, what is the point group of this one, cis one? Yes, its point group is C2B. This is your C2. This is also a plane. So this is C2B. Now for this one. Yes, this is your C2. C2. And then this is the plane containing C2. Is from here. The sigma H is plane is containing all the four atoms of the molecule. So it is C2H. Now tell me this one. This is open book structure. This book is open, just like that. So there is an, okay. Let's say this is book. This is a open book structure like this. O is here, one O like here, one O is here, one O is here, and one H is in this page, one H is in this page, like this. Patlekha, you are not replying. Are you there? C2. So C2 axis is going from here. Okay. Next, what we have? Do we have sigma, plane of symmetry, anything? No plane of symmetry. Okay. Are you able to follow? Nafa. Okay, wait. Okay, sigma h. You are saying sigma h. Lekha says. Now why saying sigma h is present, right? Okay, I told you this is your open book structure. This is open book. O is present here. One O, second O. One H is here. One H in this page here. So now tell me where is sigma H? C2 is there because in the middle here. If you rotate this, you'll get the similar structure, like similar orientation of the molecule. So C2 is there. That I know for sure. So where is sigma H? Sigma H must be perpendicular to sigma C2. So I told you this is C2. So perpendicular to C2. So if this is open book structure, I am saying C2 is this. C2 is coming from this. So sigma H should be like this. So I don't think so because this will invert your molecule. This will invert. Yes, no, like this. Sigma H will do this. If you place the mirror here, it will invert your molecule like this. So sigma H is not present, definitely. So this is wrong. This is wrong. Now sigma H is not present. Sigma V is there or not? Tell me. Sigma V is there or not? Anywhere. Just imagine. Let's say I told you this is sigma. This is your structure. This is your structure. Now try to find out where is sigma V. Sigma V, you know, it contains the principal axis. Sigma V always. So this was your principal axis. This was your principal axis. This was. If you consider this your sigma V, let's say it is cutting, it will not going to give you the similar orientation of the molecule. Let's say you consider this is also not give you the, because this is not like one O is here, one O is here. This H is here. This H is here. This H is here. One H is here. One H is here. I don't know you are able to follow or not. Like this. So let's say one H is here, and here one H is present. Let's say here. So if you cut it from here, from the middle, like the mirror is present here. So this H will invert here. This H will invert here. You will not get the same orientation of the molecule. So sigma V is also not present. I think you are not able to follow. I believe. Okay, nice. So only C2 is present. So what is the point group? Tell me, what is the point group? So I think yes, point group is C2. So now this is third class. You should not take that much time, because if the flow chart, if you remember from last class, first you look for the symmetry element, the higher order of symmetry, tetrahedral, octahedral, and then you look for this rotation axis of symmetry, then you look for this principal axis of symmetry, then there was principal, then subsidiary axis of symmetry C2, which is perpendicular to principal axis. If it is there or not, if it is not there, then C point group. If it is there, then D point group. Then look for plane of symmetry. If it is there, then sigma H will come. If it is present, if it is not present, sigma V, just like that. So sigma is not present, only C2 is present. So your point group is C2 simply. Point group is C2. Okay, anyways. Okay, new example. A, 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 A. Now, tell me the point group of this molecule. All of them are A. All the atoms are A here. D3H. Yes, D3H. Okay. Next, A, B, A, A. Tell me the point group. C2V. C2V. Yes, C2V. Okay, next. A, B, B, A. Tell me what is the point group? Patlekha, you are not replying. C2V, yes, C2V. Okay, next. A, B, A, C. Okay, what is the point group? This one and this one. A, B, C, D. Tell me the point group of these two molecules. It is C1. C1, okay. For which one? C1. This one or this one? Or for this one, it is C1. Or for this one? Someone, okay. Surendra. Yeah, tell me. Okay, nice. Nice question. That is why I thought you know, but that is why you are not able to tell. Okay. C1. Okay. Ci. Cs. These three you should remember because these are not so common, but because people don't usually ask such molecules because it is very easy. So we usually forgot. Okay, anyway. So C1 means any molecule you are rotating. Let's say C2. What does that indicate? C2 means there is one axis present which is rotating the molecule y 180 degree and giving you the equivalent orientation of the molecule, right? So it is like Cn 360 divided by n, right? So if C2 is there, means 360 divided by 2, which is equal to 180 degree. 180 degree rotation is there. Let's say in the case of C3, it should be C3 360 divided by 3. It should give you oh yes 120, yes, this, which means if C3 is present in any molecule, let's say this is your molecule, BF3. If C3 is present, which means you are rotating the molecule by 120 degree and getting the equivalent orientation of the molecule. So let's say FC1 is there, which means 360 divided by 1, which means 360 degree. So basically, you are rotating the full molecule, like the molecule by 360 degree. So this is C1. You are getting the identical structure, identical orientation of the molecule. E. Now, CI, for example, is for CI only inversion is there. Okay. Oh, yeah, this molecule should be okay. CI, okay. F Cl Br. So here CI is only present. If you look closely, only CI is present. Only inversion center is present here. This is your inversion center. Because this is this Br will go here. This will exchange their position. These two will exchange their position. So only Ci is present. If you try to find out any other axis of symmetry or plane of symmetry, you will not going to find it, because if let's say this is the place here, you will able to find out this is the place here. If you try to find out the C3 or C2, this F will go to here, this Cl will go here, so you will not going to get the similar equivalent orientation of the molecule, which means no axis of symmetry is present. If you try to find out the plane of symmetry, let's say if you cut this molecule here, this Cl will go here, this Vr, you will not going to get the equivalent structure of the molecule, orientation of the molecule. So plane of symmetry is also not present. Only these two are not. Again, inversion center is only inversion center is present. That is why, like, E is always present. It is identical structure. So Ci means only invert I is present. Okay. Now coming to this Cs. Cs means E is always there, but molecular plane is there. Molecular plane is there. No other symmetry is present, but in that particular molecule, this plane of symmetry is present. Sigma, in which all the atoms of the molecules are present. So now you understood the difference between these two. I believe so. Okay. So now tell me that the point group of this molecule and this molecule. Yes, both are Cs. Because you cannot rotate the molecule. If you rotate the molecule, If you try to find out the axis of symmetry, it will change its orientation. If you try to find out the plane of symmetry, then one sigma h is present. One sigma h is present. But you know that only sigma h is present, then you cannot say the point group of this molecule is sigma h. So this should be Cs. And obviously I is not present, inversion center, because if this you consider this is your inversion center, this A will go here. Here is nothing. Similarly here. So both are Cs. Okay, nice. Moving on. Let's say take some example of tetrahedral molecules. Oh, I already told you. Anyway, CH4. See. So knowing the now right till now I am telling you the structure of the molecule, but for, for finding the point group of the molecule, you should know the structure of the molecule beforehand. So let's say I'm giving you this one CH4. So I'm telling you. See, this is this. So this we know. This is tetrahedral. This is tetrahedral. Okay. Anyway, point group, because this is higher order of symmetry is present here. Maybe in this class, what is the time? 4:40. Maybe in this class or in the next class, I will visually also show you the molecules, like how you can rotate and how they will look. So anyway, this is higher order of symmetry. Higher order of symmetry is present in this molecule, tetrahedral. Anyway, let's take another example. A C B3. Now I'm telling you, let's say it is in this form, tetrahedral form. So let's say I'm drawing the structure. This is your C, B, this is your B, this is your B. Now tell me the point group of this molecule. Or if you are directly not able to find it, simply follow the procedure. Axis of symmetry, second, plane of symmetry, third, I, fourth, IUS. If you find these, then no need of finding this. Anyway, try to find out the point group of this molecule. What are the axes are present? Axis of symmetry is there or not? And which axis of symmetry is there? If axis of symmetry is there. C3, C3. Yes, C3. Yes, C3 is present. C2 is there or not? No C2. Okay. Okay. No C2 is there. No C2 is there. Then find out the plane of symmetry. 3 sigma V. 3 sigma V. 1, 2, 3. Yes, 3 sigma V's are there. So what is the point group of this molecule? C3V. C3V. Yes. Are you able to follow, Nafa? Okay, nice. Okay, next, similar to this. C C B B. Tell me the point group of this molecule. Sir, is C2, sir, is C2 there? C2 is, yes, C2 is there. Nice. This was actually, yeah, difficult to visualize, but okay, it is fine. C2 is there. Then axis, oh no, any plane? C2 sigma V. Okay, sigma V. It will be containing this and this. We'll divide these two. Okay, sigma V is there and containing this, passing through this C2 also. Sigma V is there. Then how many sigma V's are there? How many sigma V's are there? Two. Yes. One, it will contain this and this and this. It is like this is the plane. This is the plane. In the plane, A is there, C is there, this C is here. But this is above the plane, this is below the plane. Below the plane. And another one will be having this and this V and this V. These two will be out of the plane. So 2C2, 2 sigma V. So what is the point group? Asu, Rawat, tell me what is the point group of this molecule? C2V, yes, C2V. Yes, C2V is the point group. Okay, next. Moving on. I think I have already introduced you about this uh, linear molecules, but let's say take this example. Let's say O2. Tell me, what are the axis of symmetry is present, plane of symmetry is present, and what is the point group? How many axis of symmetry, plane of symmetry, which one is I, IUS, and then point group? Tell me. Maybe I should draw it a little bit. Okay, now. Also tell me, any axis of symmetry is present here or not? C3, C3. 3 C3s? C2s? Also, yes. C2. Okay. So I think if you are saying C2, then you are considering this C2, right? But Nafa said 3 C2s. Nafa said 3 C2. I'm not able to find another C2 other than this C2. Is there any other C2s are present? Nice. Okay. If you are saying so, why not? Why not? Yes. Okay. One C2 is there. Next, tell me another C2. This is planar molecule. This is your planar molecule. Like this. This is your O. This is your O. This is your O. These two are O. So you are now considering one. I'm talking about this C2. This C2. So now you are considering this C2. So you are rotating along this axis. So I'm rotating this along this axis. Okay. You got the equivalent orientation of the molecule. Okay, fine. Now Nafa said, why not between the passing through the O atoms from here? Okay, I said okay. Then rotate the molecule by 180 degree. Okay, I have rotated the molecule by 180 degree. Okay, equivalent orientation. Now again you are saying this is your like xy plane. Let's say this is your z plane. So z you have considered. This is your, let's say, x. Now left is only y. So you are saying this one, right? And one is this one. So basically you are saying this one and this one, right? From the top, you will rotate. From this side, the y-axis, it will be like this one, like this. And from x-axis, you are rotating like this. Okay, fine, nice. 3 C2s, whatever you have considered is correct. But there is a mistake. There are infinite number of C2s present. Am I correct? Yeah, sure. So first, let's say, first you try to find out C infinite. Is there any C, like, are you able to find out the C infinite? Yes, from here, right? You can rotate it by 1 degree. You'll get the same orientation, or 2 degree, or 3 degree, or 140 degree, whatever you wish for. You'll get the same orientation of the O2 molecule. So C infinite are present here. Similarly, from this axis, consider this is the molecule. So if you like, no, I think you are correct. C infinite is there, but no. I think infinite C2s are not present. Yeah, no, yes. Okay. In the starting, I told you, if your principal axis is Cn, and if you are able to find any C2, then there are n number of C2 present. And if there is no C2, then if you are able to not, then if C2 is present, then NC2 will be there. if it, and otherwise no C2s are present. So here in this case, C infinite is there, and we are able to find one C2 here, one C2 here, one C2 along the x-axis from here. So 3C means you have infinite number of C2s. This is, I have told you in my first class, I guess. And from this O, now I can explain this. Let's say consider this from here. You try to rotate the molecule by taking any orientation. Let's say let's say consider 0 degree. You are, let's say, considering you are rotating the molecule by C2, then you will reach to 180 degree. Same orientation of the molecule. Let's say consider you have taken 1 degree. As from the 1 degree, your C2 axis is passing through the molecule. This 180 degree you will get, but your orientation of the molecule will be same. Just like that, you will have infinite number of C2s here. Anyway, yeah. Now, anyway, you now got the C infinite number of C2s. Now, tell me what next is left for this molecule. Is there any plane of symmetry is present? If present, which sigma h? Yes, sigma h is there. Yes, because this is your principal axis, so this is your sigma h. Anyway, okay. Now next, any other sigma h? Yes, sigma h is present. Any other axis is present? Sigma v. Yes, sigma v is present. Considering this here is sigma v along the principal axis of rotation. Yes, sigma v is present. Now tell me how many let's see, sigma h is, this sigma h is always perpendicular to principal axis. So principal axis is always 1, and this sigma h is always 1, perpendicular to the principal axis. This relation you already know. Now tell me how many sigma v's are present. Yes, infinite number of sigma v's. Just the same, like this. If you consider the plane at 0 degree, this is your molecule, OO. Consider this molecule is cutting the molecule, infinite, yes. This is your, at 0 degree, sigma v is present. Let's say I am tilting little bit. This is 1 degree, this is 2 degree, this is 3 degree, let's say this is like this. So infinite number of sigma v's are present, and you will going to get the same orientation of the molecule by applying the this symmetry element, this plane of symmetry to the molecule. Okay, now what is the point group of this molecule? Now you know everything. Now you know all the symmetry element of the molecule. Now tell me what is the point group of the molecule? Asu, tell me. Okay, D infinite H. Nice. Okay, another molecule. D infinite H. Yes. Now you know, I think I have something interesting for you guys also. Let's see, consider. Okay. Are you able to see my screen? Okay. Tell me, what is the point group of Qutub Minar? This is a Qutub Minar. Yes. Yeah. Tell me the point group of Qutub Minar. somebody, okay, now was saying C infinite. C infinite for this Qutub Minar, right? So C infinite for Qutub Minar, what is C infinite is, okay. C infinite is present. Next, this is your axis of symmetry, right? Any other axis is present other than the C infinite? Okay. And plane, is there any plane is present? Okay, some Patleka is saying C2 is also present. So that is why I asked you, is there any plane of symmetry is axis of symmetry is present or not? Okay, let me, I think, okay. For you, let's say this is your O, this is your O, this is your U. Now tell me, is there any other axis of symmetry is present or not? This is your this is your O2 molecule. It was like this. I have just tilted like this. Just similar to Qutub Minar. Just tell me now. C2 is there. Yes, C2 is there. This is your C2. So here, this is C2 is present here. Now you have found one C2, right? How many C2s are present now? Yes, yes. Now see, you have got zero C2s, zero other axis other than the C infinite. Now, now you have infinite number of C2s axis. So that is why I am saying you should look closely. Like visualization is very important. Okay, now C infinite is there, you know, and infinite C2s are there. Now tell me, any other uh, symmetry element is present or not? I'm not saying axis of symmetry or plane of symmetry, inversion or anything. Just tell me any other axis, any other symmetry element is present here or not. Yes sir, no sir. Okay, different answers. Tell me, if those who are saying no, which means they have not found it. Those who have found the any other symmetry element, tell me which symmetry element you are able to find it. Sigma V, yes. Sigma V is like this. This is your plane. Okay, sigma V. So how many sigma V's now you are able to find? Infinite, exactly. Okay, any other symmetry element? Infinite sigma V, yes, infinite sigma V is there. Tell me, any other symmetry element are present or not? Sigma H. Where is sigma H? See, infinite number of sigma V's are present here along this axis. Considering this C infinite, but this is also your C infinite. So sigma H should be perpendicular to this C infinite. So it should be like this. So it is not like a cube this what you call cylinder. This is like, it is going like little bit like this conical shape is there. Got it, sir. Yeah. So there is no sigma h. There is no sigma h is present. Anyway, so now tell me, what is the point group of this molecule? Tell me the point group now. Huh? D infinite H. C infinite. C infinite. C infinite is the point group. You are saying. Yes, sir. Yes, sir. No, you both are. No, see. C infinite is there. C2 is also present. But C2 is not perpendicular to C infinite V. Yes. This is correct answer. This is C infinite V. So, okay. You know this one. C infinite V. Now, find the point group of the Taj Mahal. Just imagine this Taj Mahal is, I'm showing from the front. If you remember this, actually architecture of this Taj Mahal, then you will able to find it. Otherwise, it will difficult for you to find the point group of the molecule of this Taj Mahal. Asu, tell me. D2H. Okay. D2H. No, actually. D2H is not correct answer. Why? Okay. So, my question is that, have you visited Taj Mahal? Yes or no? No. Okay. So this Taj Mahal is same from all the sides, from all the four sides. The architecture of the Taj Mahal is same from all the four sides. So this is whatever you are saying is from the front. This, this. If you like, you are standing here. This is Asuravar. Asu, yes, Asuravar. You are standing and you are seeing from here. This is your, okay sir, okay sir, okay, here. Now, let's say you are standing here, here. You will get, if you are seeing from here, you will see the same architecture. If you are standing here, let's say, you will also see the same. Or if you are from the behind, you will see. So, what is the point group now? Tell me. Or you have guys told already. No, okay, D4D. D4D. Nafa is saying D4D. D Patlika is saying D4H. Now Asu, tell me, what is your answer? D4H. Okay. D4H. Okay. Okay. Now see, if you, let's say you are here in the plane or in the helicopter, you are here, right? Now you are looking at the Taj Mahal from the top. You are looking from here. So this is your axis. This is your axis. So I told you it is similar from all the four sides. So this should be C4, right? Perfect. Now if C4 is there, C2 is also there, because now C4 is there means you are rotating this Taj Mahal by 90 degree. If you are rotating by 90 degree, you are getting the same orientation of the Taj Mahal, which means you can rotate it by 180 degree also. You will get the same orientation. So C2 is also present there. But how many C2s are there? Now tell me, how many C2s are present here? Four. Asu Patlekha are saying 4. And Nafa, tell me, how many C2s are present here? I can see only one, sir. Yes, there is only one C2 present. How you guys are saying that 4 C2s are present? This is the axis only. This is the axis only. You are rotating the Taj Mahal from here. You are rotating the Taj Mahal from here. So previously it was C4, which means you are rotating 90, 90, 90, 90. Now you are rotating the Taj Mahal by 180, 180, 180, like 180, 180. So only one C2 is there from this. If you try to find out from this, like, see, there is no C2 is present. He will literally, you flip the Taj Mahal. So only one C2 is there. Only one C2 is there. So here is one C4, one C2. Okay, now next find plane of symmetry. What is the plane of symmetry? How you guys have said H is present, which means this is C4. So perpendicular to this C4, there should be one plane which is giving you the same orientation by applying this symmetry element. Okay. So perpendicular to this C4, this is your plane. Like this is your Taj Mahal, this is your C4, and this is your sigma H, right? So if you apply the operation, this mirror, you will literally flip the Taj Mahal upside down. So there is no sigma H present. There is no sigma H present because this is your principal axis. Am I right or not? Are you able to follow, or I'm just yes sir, yes sir. Okay, nice. So sigma H is not present. Now tell me, is there any axis of symmetry, any plane of symmetry is present? Asuravat, yes sir. Okay, tell me, is there any axis of plane of symmetry present? (2D planar). What is 2D planar? Sigma V, yes, sigma V is present. So sigma V is like this. Like this. So how many sigma V's are present here? Sigma H 4, yes. 4 sigma V's are present. So Taj Mahal like this, 1, 2. Now, other than 2, tell me, where are 2 sigma V's are there? 4 sigma V. Okay, tell me, where is 2 I know. 2 I know. So this is your Taj Mahal. Let's say this is your Taj Mahal. This is your first sigma V. This is your second sigma V. Tell me other sigma V. Diagonal. Mm, I think you are right. Diagonal, yes. Because if this Taj Mahal is too symmetrical, yes. This is also present. Okay. Now tell me what is the point. Now you know everything. Now tell me what is the point group of this molecule. 4 sigma V is also there. 4 sigma V. Tell me what is the point group of this molecule. Huh? Who is saying diagonal D4? Why D4? C4V. 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 Sorry, sir. C4V. Yes. Point group is C4V. Yes. Point group is C4V. So if someone asks you what is the point group of the Taj Mahal, now you will able to tell him the answer that point group of the Taj Mahal is C4V. This is the correct answer. C4V. These all answers are wrong. And point group of this Qutub Minar is C infinite V. Next, again, tell me point group of this Red Fort. Just consider this image only. Forget about the full Red Fort. Or just consider this picture. Just consider this picture and tell me what is the point group. C2V. Okay, C2V, fine. Yes. Asu, are you able to follow C2V? This is your C2? No. Okay. So if this is your C2, let's say this is your C2 going from the middle. This is your C2. This is your C2. Like this. This is your C2. 180 degree. Like this. So this is your C2. Now sigma V is the plane which is cutting, like going imaginary plane which is going inside between the, like considering the C2 axis passing through this red fort from the middle. This is your plane. This is your plane. This is your plane. Should be like this. This is your plane. You are rotating like this, and this is your plane. So this is C2V. So sigma C2 is present and sigma V is present. So point group is C2V. Now it is fine, Asu, or V is 90 degree, right, sir? is 90 degrees. Sigma V, no. 90 degrees sigma h, no. So this is your principal axis of rotation, C2. If 90 degree of this plane will look like this plane, this plane. So this is not present. So sigma h is not present. So this is sigma v. This is sigma v passing through the C2 axis. Sigma v, like this sigma v always, this sigma v always contains principal axis of rotation. Always passing contain. So if any plane perpendicular to the axis of rotation, which should be, it should be sigma h. So the sigma v is there. So point group is C2v. Now it is fine, I guess. So no, now I can understand. Okay. Okay, something interesting is here. Tell me the point group. Tell me the point group of this. What is this? Tell me first. What is this? This first image, A. What is this? B, you know. Lotus temple. Yes, lotus temple. Now tell me the lotus temple. Yes. Tell me. What is the point group of this? Or not start jumping on the point group. Try to find out the symmetry elements. What are the symmetry elements are present? Or if you have any confusion, you should ask. How many petals are there? Accordingly, you can so 1, 2, 3, 4, 5, 6. I can't find, sir. 7, 8, 9 and 10. Okay, anyway, leave this example. It is maybe in the next class I'll try to show the full image of this, because it is difficult to explain also for you. Anyway, moving to this cup. Tell me, what is the point group of this? C1. C1. Okay. C1 means identity element only. Ci means inversion center and identity element. Cs means infine this sigma h and identity element. So someone said C1. Okay. I think Nafa said C1. Tell me Asu and Patleka. Asu is saying, or he is saying also C1. Patleka is saying CS. Okay. Actually, the correct answer is CS. Why so? Because in CS the sigma s is present, right? If sigma s is present, means that if you literally try to pass the imaginary plane from the middle of the cup, from the left, patli ka left, okay, anyway. So this, try, okay, see is back. Okay, try to see this imaginary plane is passing in between the passing between the cup. It, it is bisecting this also in half. It's just like you have cup, you don't have cup here. Okay, anyway, let's say we have this glass, right? Here is your handle, cup handle. You are holding like this. Now try to pass an imaginary plane in between here, from here. So it will bisecting half the cup here and here, there and here, and this is also bisecting the handle of the cup in two parts. So now tell me, sigma s is present or not? I think I'm clear or not? Are you able to follow or not? You guys, yes sir, yeah. Sigma s is present here. Sigma s is present here. And E is always there. So, and other than that, there is no axis of symmetry is present. So, if axis of symmetry is not present, sigma s is present, which means point group is CS. So, you two guys are wrong. Patlika was right. Anyway, okay. Tell me the point group of this conical A1, A, point group of this test tube B. Tell me the point group of these two. Okay, cup like this. This is cup like this. So this is the handle. This is the handle. This is your cup. This is your cup. You are handling like this. So you cut from here. Now I think you will be able to imagine more. So anyway, tell me. Sir, we are talking the design of the flask into huh? Are we taking the design of the flask into consideration? I mean, this is conical, yes, of course. Design means you are don't consider this borosil or this is written. This is nothing is written here. This is nothing is. This is plain just. Okay, sir. Tell me now. What is the point group of this and this? Patlika has given the answer of this one. This one, CS correctly. Now, Asu, you gave answer for any one of them, and Nafa, you also. You should give one answer correct. What is the point group? Tell me. If you're like not able to find the point group, simply follow the same procedure. Simply AOS, POS, IOS. Then follow the chart, whatever I said in the previous class, that finding the point group. In this class also I have briefly discussed. It is C infinite V for first one. Yes, C infinite V, correct. Yes, C infinite V, it is right. This is your C infinite and V is, yes. Second also. Yes, C infinite V. So did you like these examples? These examples, this lotus, red fort, anything? Yes sir, I enjoyed. Okay. Actually, I thought of also taking some other examples, but yes sir, yes sir. Okay. Now coming to our business. Coming to this assignment, this is week 0 assignment. I think you guys able to solve it, but still, it's one. What is the question? One or more option may be correct for the following statement. Find them. For the following molecule given above, symmetry elements that are not present is oblique R. So not present. So first one is point of inversion. Is present or not? Tell me, Asu. This one you should answer. This one you should answer. Point of inversion is present or not? No, sir. No. Yes. Point of inversion I is not present. Okay. So the question asks, what are the symmetry elements are not present? So this is your answer. Next, because here written is or are, one or more option are may be correct. So let's look for another C2 axis of symmetry is present or not. C2 axis, yes sir. Okay. So you are saying C2 axis is present. Yes, C2 axis is present from going from here. This is C2 axis. This is your molecule. X is here. X is here. This is your C2. So just like this, just like you are flipping the molecule. Yes. So this is not your answer. They have asked what is not present. Next, C4. Excess of symmetry is present or not? No, yes. No C4. And mirror plane, any plane of symmetry is present or not? No. Yes. Mirror, this mirror plane is also not present. Other than Patlikha, are you guys able to follow Nafa and Ashu? Huh? No. Yes, sir. Okay. Tell me, Ashu, what is the confusion? Are you able to follow this point of inversion? Is not present, right? You should reply, otherwise. Ashu, are you able to follow this point of inversion? Yes, sir. Yeah, because point of inversion, if you consider here, see this x will what? Where this x will go? Here. This x will go here. So point of inversion is not present. C2 is present. I already told you. Like this is here. This is your C2 is present here. But C4 is not present because you cannot rotate this molecule by 90 degree and get the similar orientation of the structure. So C4 is not present. So you try to find out this. Let's say this is your C4 from the above. You are applying like from the above you are rotating the molecule, but you will not get the similar orientation because this x will go here. This x will come here. This it will go there. So after applying the C4 from this, let's say this is your C4. So it will be like something like x or x, maybe like this. This structure you will get because 2x were here. These 2x will come here. This will go here. This will go here. So it will. So this structure orientation of the molecule is not similar to this one. So C4 is not present. Anyway, mirror plane is also not present. If you try to find out this plane here, this is also not present because this is below the plane. This is above the plane. So mirror plane is also not present. Anyway, next question. For an H2A2 molecule, both cis and cisplanar transplanar conformation. This I already told you, I think. Okay, anyway. This is O, H, H. This is cis, this is trans. Now tell me what the C2 is present as a principal axis. C2 is present here. I believe so. C2 is also present here. C2 is present. Correct? Yes. C2 is present. Yes. Sigma H. Sigma H is present or not? Surawat, yes. Okay. Sigma H. Are you able to follow sigma H? No. No. Yes, sigma H is not present in both the molecules. For cis it is present. How? This is your C2 molecule. This is C2 axis. So sigma H is perpendicular to this. perpendicular to this. It will fill up your molecule. These two O to H. After applying the sigma H, it will go like this. So sigma H is not present in this. Sigma H is present in this one, trans, because your C2 axis is like here. This is your C2 axis. Rotating from here. In this it is present sigma H. Anyway, both here it is written both in. Anyway, possesses sigma V. Sigma V is present here. Sigma V is not present here. Here, sigma V is present here, but here sigma V is not present. So this is also gone. H2. H2 means you should have C2, then sigma. And this, let's say this C2 is Z axis, then sigma, this sigma should be X by perpendicular. So we have already said this, sigma S is not present, which means S2 is not present, right? Second A. Okay, this one is done. Now coming to question number 3. This I don't know in your class, because I am not told you how to do this, but in your Anindya sir class you guys have learned it or not, but I don't know, but I am going to solve it anyways. So 3, 2, 5, 8. It will be like 3 into 4 plus 2 into 6. And here 4, 5 into 4, 8 into 6. This. It is like this to this to this. Again for this to this to this. 1 is right, 3 is right. Okay. 12 plus 12, here 20 plus 48. 24 and how much? 8, 6. This is correct. Number 3. Are you guys able to follow, right? Option 3 is correct. Yes, sir. Okay. Question 9. No, question 4, sorry. The combination which have the subgroup. Okay, this is I don't know. In the next class I will solve, because I haven't told you the subgroup of this. So for a group with H equal to 6, the subgroup with H equal to 3 is a cyclic, never cyclic, can be cyclic, depending on the group, does not exist. If you know the answer, tell me. No idea, sir. Okay, in the next class, this is also, because if you have no idea, which means theory is required first, then question answer. Okay, this molecule. Okay, this is interesting. You guys need to tell me what is the point group of this. you're not able to see if it is small, let's say oh, it is drawing, no, some. Hello guys, are you able to see me? Nafa, Patlekha, Asu, Shivam. 7 people were there, no? Somebody left. Are you, Patlekha, yes. Are you able to see my screen? And you are able to listen to me or? No, I think mute. I'm mute. Now you guys are able to see me and are you guys able to listen to me? Yes sir, okay, I'm audible now. Okay. Connection, Patlekha, okay. Okay, tell me point group of this molecule. D3. Okay, D3 means you have C3 and C2s. Correct. D3H. Someone is saying D3. Asu is saying D3H. Where is D3H? Huh? D3H is not in the option, Asu. I think it is difficult to visualize. That is why you guys are a bit confused. No sir, D3. So C3, this is your, from N, it is C3 is passing, right? From here. And C2 is just this. This is your C2. This is your C2. So this benzene, this chlorobenzene, 6-chloro, this is not planar. This is like, this is vertical. So now this is your C2. This is considering this is also. So if you applying this symmetry element, if by this operation, you will flip the molecule like this. So this is present, this is also present. Tell me, how many C2s are present in this molecule? C3 you know, but how many C? 3, yes. From one here, one here, one here. Yes. So answer is C. First C. This is because principal axis is C3, perpendicular. 3 C2s. So you will get the point group of D, 3. Then you will find the this what you say this plane of symmetry PUS. But here any plane of symmetry is present or not. So if plane of symmetry is not present, then this will be your point group. I think plane of symmetry is not present because this is if you, plane of symmetry is not present. No PUS. Because if you pass the imaginary plane uh, consisting this benzene molecule, these two benzene molecule will reflect other ways. Like this is like this benzene is like this vertical, and this benzene is going this side, this side. So if you pass the plane from the between, so this will go this plane will like be this, and this benzene will be like this. So the orientation will be different. The orientation is like this for both the benzene molecule. So by applying the imaginary plane, their position will shift, so it will be like this. This will like this and this. This it will be like this and this. So no plane of symmetry is present. That is why it is D3. D3. Next, are you able to follow this? This one. Yes, sir. Okay. Okay. Tell me. What is the symmetry element that are present in this molecule? This is interesting actually. This is interesting. The first thing is that you first have to think how to solve it. First thing is that how to solve it. That you first have to remember. Like first you have to think. Without it is difficult to solve actually. Okay. Since you are not replying, then we can rewrite this as now. Is this right or not? These two are equivalent or not? Tell me. Yes. Yes. These two are equivalent. That is why I told you. First you have to find out how to solve it. Because in this structure it is very difficult to actually visualize and do the this operation symmetry operations. It is very difficult, and you will also not able to find the correct answer. Forget about answer, you will not able to do the operation also in this structure. So that is why you have to first remember how to solve it. So we can simply rewrite, like redraw this structure like this, right? So now you can tell me, both of you, three of you, four of you, sir, but the atoms are on alternate carbons, right? Alternate carbons means no, na, one This is 2, this is 3, this is 4, this is 5, this is 6. Okay, yeah. So this is your first, second, third, fourth, fifth, sixth. Now tell me, what is the symmetry element that are present in this molecule? Then we will also find the point group of this molecule. They have not asked, but we will find out what is the point group of this molecule. Try to find out. AOS, AOS, POS, I, and IOS. So tell me, axis of symmetry. What are the symmetry elements are present? What are the symmetry operations, symmetry axis of symmetry are present? C is right answer. C is right answer. Okay, that is fine, but first tell me the axis. What are the axes are present? Sir, I can see C2. I can see C2. Yes, C2 is present here. Okay, how many C2s are present? C2. One. No, you guys are still saying one. This one C2 is present. This C2. This is also no. This is this C2 axis, because after operating this axis of symmetry, this C2, this Cl4 will replace by Cl1. This 6 position replaced by 3 position, and this is your axis, and this is your here. This is your axis. These will be replaced. So 2 C2s present. No, 2 C2s. You guys are not replying or what? Okay. Sir, I can say C2 1 1. Okay, sir. Okay. Yeah. So 2 C2s are present, and these two are perpendicular to each other, or not? Yeah, tell me that also. These two are perpendicular to each other or not? Yes, Ansu is saying yes. Nafa, you tell me. No, this is your cyclic molecule, no? This is your cyclic molecule and planar molecule. So if this is one C2, this is one C2, this is one C2 like this. In the plane only. This is planar. Okay, we are saying for this one, right? This will go here, huh? Hmm. Hmm. Yes, you're right. You're right. You're right. No, no, two C2s are not present. No, only one C2. Yeah, you are right. You are right. This is wrong. Only this C2 is, I think, present, right? Through the here. Uh, hmm. Okay, this is okay. Whatever you are saying, this is correct. Whatever I told, totally wrong. Yes. This C2 is also not present. This C2 is also not present because this C2 is passing from these two bromine. This Cl will come here. This Cl will go there. Yes, just like this. So 3 1. No, no, no. Only whatever you are saying from the plane. From the plane. This C2 is present. Yes, I was wrong. I was wrong. See, I am also making mistakes. It's like that. So no problem making the mistakes, but you have to learn it. Anyway, so this is only C2. This is only one C2 is present, which is going perpendicular to the plane. Only that C2. You understood what is the mistake I made? Got sir. Yeah. So only one C2 is present. Now tell me any plane of symmetry is present. You guys have said this one is correct, right? So if that is the case, then tell me where is sigma d? Sigma h, yes. If that is the case, then tell me number two, question two. Answer is D. No sigma d, C2. This is interesting, huh? I is present. Answer is Okay, maybe in the next class I'll solve this example because I'm also a little bit confused about this example. I'm making mistakes. Yes, probably my probably my brain is not braining right now because this is I made mistake. Yes, I am. Okay, in the next class. Okay, in the next class we will going to solve these other examples. Assignment 2 also. Assignment 2, 3, 4, whatever we have, we will going to solve it one by one. And other examples like this Taj Mahal, Qutub Minar, Red Fort, Lotus Temple, Carp, Borosil, and this conical and this test tube. We'll see other examples also. So in the next class, we will going to have some interesting these images, and then we will going to solve the point groups of this. And also I have lot of questions to solve, but yes, anyway, this is looks like you guys are reading this for first time, so of course it will take time. See, in the end, after 2 hours I am also making mistakes for this example, so it happens. So maybe maybe in the next class no, not maybe, for sure we will going to solve in the next class. So till now, please join next Sunday 4 p.m. So we will going to solve and learn. So I enjoyed teaching you guys. So tell me any feedback. Am I like too slow, too fast, not clear? I too enjoyed, sir. Okay, not clear, or you want anything specific from me to teach? Anything? Just suggestions. So in the next class I will consider those suggestions. Then it will be more interesting. I thought of doing this. This is while teaching. I also like find interesting. I'll solve this example. Lotus Temple also. This one I find very interesting. Everything is fine, sir. Sir, I want to ask a question. Which book is the best to understand the basic concept of group theory? So this is F.A. Cotton. F.A. Cotton. Maybe in the next. Okay, go to my this material section. I will upload there, so you can download from there the book or whatever material I have from my bachelor's and master's. I will upload, so it will be easy for you. But I am telling you the one name, which is F.A. Cotton, which is very. This book is very. I mean, very very good. I mean, F.A. Cotton. But book is good, but the language is very difficult in this book. I think I have read like 2-3 years back or 4-5 year back. So language is quite difficult. I'll okay. I will upload in the material section. So you go to that spreadsheet, Google spreadsheet, in which you will find my video lecture. Also the material. In material, I will this upload the book. Whatever material I have, I will see also like which one is best for you, because this F.A. Cotton is English language is very difficult in that. Whatever I can remember, because I was trying to read the F.A. Cotton, but in halfway I have stopped reading the book. Then I have started something else, reading some other book. So anyway, okay. I will going to end this class here, and please join again on Sunday, next Sunday, coming Sunday, 4 p.m. Okay, bye bye guys.